Hi class, right now we're going to be going over lesson 7.4, how to use probability models. So we'll start off with our two definitions for this section. The first one is that of a sample space. So the sample space is the set of all outcomes. We're going to show how to write that in just a moment here. And then the probability model. The probability model consists of the sample space of an action, events within the sample space, and probabilities associated with each event. So our key concept for this section is that a probability model can help you evaluate a chance process and its outcomes. You can develop a model using theoretical or experimental probability. A probability model consists of the sample space of an action, events within the sample space, and probabilities associated with each event. So here's our first example. Murray spins the pointer shown to the right, and we want to come up with first our sample space. So the way we're going to write our sample space is we're just going to list all possible events we have. So here, we can land on a 3, another 3, that's both of these here, a 5, an A, or a Y, or a Y. All right. So we can see here we have a 3, a 3, a 5, an A, and a Y, and a Y. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. And it's asking us the probability of each event in the sample space. So what's the probability we would land on a 3? Well, we'd have 2 out of 8, which would be equal to 1/4, right? And this is our probability. All right. Now how about our probability of a 5? Well, we also have 2 out of 8, or 1/4. Then the probability of an A would be 2 out of 8, or 1/4. And the probability of a Y would be 2 out of 8, or 1/4. So right there we came up with our sample space, right? So all the sample space was is we listed out every single option in parentheses here, right? And we just listed them one by one. And then we used that as a visual representation to come up with our theoretical probabilities here. Let's go to our next problem. So a bag contains 14 green, 12 orange, and 19 purple tennis balls. So we want to create a probability model for choosing tennis balls from the bag. All right, so what are our possible outcomes here? Well, we could get a green, orange, or purple tennis ball, right? Oops, I can't spell. Or a purple tennis ball. Okay, now I'm not going to list green 14 times and orange 12 times because that would be a little bit redundant, but we do see here that we have 45 total tennis balls. All right, and that's our probability model. We have a green, an orange, or a purple tennis ball. So suppose a tennis ball is randomly selected and replaced 75 times. How many orange tennis balls do we expect? Well, first we're going to want to find our theoretical probability here. So what's our theoretical probability of pulling out an orange tennis ball? We have an orange ball, 12 orange tennis balls, right, out of 45. So our probability of orange is going to be 12 out of 45. Now I'm going to take that 12 out of 45 and I'm going to multiply it by 75 because that's how many times we are pulling tennis balls out of the bag, and we will get we'll get 20 right here. This is the answer here is 20. Oops, that looks like 26. 20, right? So we do our theoretical probability, or 12 over 45, times however many times we are conducting our experiment, which is 75 here. So 12 out of 45 times 75, which gives us 20. And finally, our conclusion here. So our sample space we learned about is just all the different results we expect from an experiment, right? And we list it in brackets, all possible outcomes. And our probability model is what we use to predict either the theoretical or the experimental probability, right? And we can use probability to predict outcomes of certain events. All right, guys.